In plate tectonics, a convergent boundary, also known as a destructive plate boundary because of subduction, is an actively deforming region where two or more tectonic plates or fragments of the lithosphere move toward one another and collide. As a result of pressure, friction, and plate material melting in the mantle, earthquakes and volcanoes are common near convergent boundaries. When two plates move towards one another, they form either a subduction zone or a continental collision. This depends on the nature of the plates involved. In a subduction zone, the subducting plate, which is normally a plate with oceanic crust, moves beneath the other plate, which can be made of either oceanic or continental crust. During collisions between two continental plates, large mountain ranges, such as the Himalayas, are formed. The nature of a convergent boundary depends on the type of plates that are colliding. At an oceanic-continental convergent boundary, the oceanic lithosphere will always subduct below the continental lithosphere. This is caused by the relative density difference between the oceanic 3.0 grams/centimeters 3 and continental 2.7 grams/centimeters 3 lithosphere. This type of boundary is also called a subduction zone. At the surface, the topographic expression is commonly an oceanic trench which forms on the oceanic side, parallel to the subduction zone. On the continental side, a chain of volcanoes forms above the location of the subducting plate, creating a mountain chain referred to as a volcanic arcade. An example of a continental oceanic subduction zone is the area along the western coast of South America where the oceanic Nazca Plate is being subducted beneath the continental South American plate. A volcanic arc is formed on the continental plate, above the location of the ongoing oceanic slab. The volcanic arc is the surface expression of the magma that is generated by hydrous melting of the mantle above the ongoing slab. Hydrated minerals, for example, phlogopite, lawsonite, amphibole, within the oceanic lithosphere become unstable at certain depths due to increased temperature and pressure, causing the crystal structure of the hydrated minerals break down and release water. The buoyant fluids then rise into the asthenosphere, where they lower the melting temperature of the mantle and cause partial melting. These melts rise to the surface and are the source of some of the most explosive volcanism on Earth because of their high volumes of extremely pressurized ether buckle and compressor. In some cases, one plate delves called subduction, under the other. Either action will create extensive